In this video, what we're going to talk about is about the angle sum of a triangle. Meaning, if we're going to add all this, the angles in a triangle, what would be their sum? So we can use this principle later on to solve for the unknown angles in a triangle and apply the same concept to more complex problems. So here we have the figure shows triangle CXD with AB being parallel with CD. So as you can see, we noticed before during the previous discussion, we knew that when we add all of these angles on a straight line, that is angle AXC plus angle CXD, the middle angle, plus angle BXD, they all add up to 180 degrees because they are angles on a straight line. So this is angles on a straight line. So when we add all of these angles, the three angles there, that add up to 180 degrees. Now we also learned that when there are parallel lines and it is cut by a transversal, we find a lot of angle relationships. In this figure, notice that because these are parallel, this line and this line are parallel, this one, this angle and this angle, which is the CDX, are also equal because they are alternate interior angles. So we say that angle BXD plus angle BXD is equals to angle CDX because they are alternate interior angles. On the other side, because again the same reasoning, these are parallel lines, we can also say that this angle and this angle here are also equal. That is AXC, angle AXC is also equal to angle XCD. And the same reasoning, that's alternate interior angles. What's the importance of stating this equality of these angles is because this is what we're going to derive for the angle sum of a triangle. Notice that since from here we know that BXD is equals to CDX, we can replace BXD with angle CDX because they are equal, meaning we can replace because they are the same. Since BXD and CDX, angle CDX, are equal, we can replace BXD using CDX, or we can replace CDX instead of BXD. The same so with AXC, we can replace that with XCD, angle XCD. Okay, because we are allowed to do that by substitution, because by common sense, since they are equal, we can use the other as a replacement of the other angle because in the first place they are equal. The AXC and the XCD are equal, so we can replace AXC with XCD because in the first place they are equal. Okay, so and we prove that they are equal because they are alternate interior angles using concepts we discussed already before. So as you can see, if we're going to neglect this one, we will have this new equation, angle XCD. Let me erase first this one, plus CXD plus angle CDX equals 180 degrees. Notice that this XCD is actually this angle, and this angle is actually CXD is this angle, and this angle is actually this angle. They are all interior angles. So what does it tell us is that the angle sum, the interior angles of a triangle, the angles marked red, those are the interior angles of a triangle. The interior angles of a triangle adds up to 180 degrees. So that is the very first concept that we should put in mind when we are trying to solve for angles in a triangle, that we should put in mind that, oh, the angle sum, the sum of the interior angles in a triangle is actually 180 degrees. So let's write that in words. The interior, meaning inside angles, of a triangle add up to 180 degrees. What's the importance of this is that it allows us to make an equation so that this equation will be our basis to find the unknown angle. So let's try to show some examples. In number 1, here we have angle A is 50 degrees, angle B is 70 degrees, and we do not know what angle C is. So we are trying to solve for angle C. But since we know that when we add all of these angles, they add up to 180 degrees, from there, we previously derived that in the interior angles of a triangle add up to 180 degrees. We will use that concept to make an equation in this problem number 1. So we say that according to the rule, it says that the angle A plus angle B plus angle C, they all add up to 180 degrees. That's what this one is telling us. We are just translating it into an equation. Angle A plus angle B plus angle C is 180 degrees. Since we are looking for angle C, we are allowed to replace angle A as 50 degrees, angle B as 70 degrees, then we have angle C, and it results to a linear equation which we already discussed before. This one is 120 degrees plus angle C equals 180 degrees. Applying linear equation, we say 120 degrees, subtract both sides. We now know that angle C, 180 minus 120 is actually 60 degrees. So yeah, this one is actually 60 degrees. So as you can see, 60 plus 50 plus 70 is actually 180 degrees. So in this problem, we solve for the unknown angle of triangle ABC. That unknown angle was angle C, and we found out that angle C is 60 degrees. Number 2 is that we have triangle XYZ, and we are looking for the angle measure of angle Y. It's the same principle. We say angle X plus angle Z plus angle Y, 180 degrees. They all add up to 180 degrees. We can replace angle X as 55 degrees, angle Z as 73 degrees, plus angle Y equals 180 degrees. 55 plus 73 is 128 degrees, plus angle Y equals 180 degrees. Subtracting both sides by 128, subtracting both sides by 128. Therefore, angle Y is 52 degrees. So we already solved our angle Y. So yeah, this one is 52 degrees, angle Y. Next problem. In the next problem, there are no given vertices. So there's no A like this. It's just plainly angle measures. So we have the first angle is 60 degrees, the second angle is 3x, the second angle is 2x degrees. We are looking for what is the value of x. Okay, what is the value of x? The unknown variable is x. So the same principle, we add all the angles, 3x plus 2x plus 60 degrees equals 180 degrees. These are similar terms, so that gives us 5x squared plus 60 degrees equals 180 degrees. Let's subtract. Therefore, we are left with 180 minus 60 is 120 degrees. Dividing both sides by 5. So 120 divided 5, it gives us x equals 24 degrees. 24. Therefore, the value of x is 24. Number 4. In this case, we have a right triangle with, when we see this, again, type of triangle, this is 90 degrees. So this is a right triangle. The same principle, we say 4y plus 90 degrees plus 46 degrees. They all add up to 180 degrees. So we are actually just using this principle, this mathematical rule. So add all these angles, 4y, 90, and 46, add it all up to 180 degrees. So if we're going to combine 90 and 46, that will give us 136. Subtract both sides by 136. We are left with 44. Dividing both sides by 4, y is 11. So that's how easy it is. Next is, there is an important concept in terms of the relationship between angle side relationship. When you go to a little bit of different geometry later in your high school life, you will realize the relation. You will learn a lot of relationships relating angles and sides. So in this concept, it says, in a triangle, the angles opposite, take note of the opposite, to the equal sides, meaning if there are equal sides in a triangle, and the angles opposite to that are also equal. Okay? The angles opposite to the equal side are also equal. So let's try to illustrate what that means. In this case, we have triangle ABC, and it says AB is equal to AC. So you can notice the equality if there are markings. So look at the figure. If there are markings, meaning they are equal sides. So in this case, since the markings are on AB and the other markings are on AC, they are the same markings. Therefore, AB is the same, has the same length with AC. So now, since these two equal sides are equal, AB and AC, their opposite angles are also equal. Okay? So we just go to their opposite angles. If this is the side, this is the opposite angle. So AC is opposite of angle B. Then if we're going to use this side, the opposite angle is that one. So we say AB is opposite of angle C. Okay? So meaning if they are equal, the angle AB and AC, at what is stated, as what the marking is telling us, meaning these angles are also equal. So you can also say angle B is also equals to angle C. Again, per definition, these two triangles is what we call isosceles triangle, as we discussed before on the types of triangles. Other illustration. So here, look at this. We have this marking and this marking. They are the same marking, meaning these sides are equal. Since the opposite of these sides is 50 degrees, meaning the opposite of this side is also 50 degrees. That's the important there. Again, the angles opposite to the equal sides are also equal angles. So let's bring that to a certain problem. In number 5, as you can see, the markings are here. And the angle opposite to the first mark is 70 degrees, meaning the angle opposite to the second mark, meaning this side is equal to this side because of the markings. This is also 70 degrees. So we are looking for x. So it's important that we know this angle so that we can create an equation in order for us to solve for x. Okay, we know that angle by the idea that, oh, this is an isosceles triangle, meaning the angles opposite to that equal sides are also equal. So we say 4x plus 70 degrees plus another 70 degrees is just 180. So it's just the same with the angle sum of a triangle. It's just that we consider the equal angles with respect to the equal sides. So we add 4x degrees plus 140 degrees equals 180. If we subtract 140 from both sides, this will become 40 degrees. Therefore, if we divide both sides by 4, x will become 10. Therefore, x is 10. Again, it's the same with this problem. The first angle is 25 degrees. The second angle is 580 degrees. We do not know, at first look, we do not know this angle. Okay? How can we set up an equation so that we can solve for 5a if this angle is unknown? But as to what we learned a while ago, the markings shows equality, meaning this side is equal to this side. That means their opposite angles are also equal. Therefore, this is opposite to that, 5a. Therefore, this angle is also 5a degrees. So we have 5a degrees and another 5a degrees and the other 25 degrees. We can now complete that, form that to form an equation using the angle sum of a triangle. So how do we do that? So there is a 5a, there's another 5a, and there is 25, add it all to 180 degrees. So 5a and 5a gives us 10a, then plus 25 degrees equals 180 degrees. If we're going to subtract 25 from both sides, we'll get 165 degrees. No, 155 degrees. Dividing both sides by 10, a is 155 divided 10 is actually 15 and 1/2 or 15.5 degrees, or simply 15.5. Therefore, the value of a is 15.5, or we can say 15 and 1/2. 15 and 1/2. That's all for this video.